titled Implementing the Data Mining Approaches to Classify the Images with Visual Words. So now coming to the introduction part, the implementation of data mining approaches to classify images with visual words represents a significant advancement in image classification and pattern recognition. With the capability to efficiently handle high-dimensional image data and extract informative features, this approach offers a promising solution to real-world challenges in various domains, contributing to the advancement of computer vision technology and paving the way for improved image understanding and analysis. Words inspired by the bag of words, that is BOW, model in natural language processing, are representative visual features extracted from images using techniques like local feature detection and description. These visual words serve as compact and informative representations of image content, allowing for efficient image analysis and classification. So now coming to the objective part for this project, the data mining approaches with visual words aims to achieve high accuracy and robustness in image classification. By leveraging the power of data mining, the system can learn and recognize complex patterns and relationships within images, leading to more precise and reliable image categorization. These visual features are then clustered to form a visual vocabulary, effectively reducing the dimensionality of the image data while preserving essential information. This step aims to create a compact and informative representation of image content, enabling efficient and effective image analysis. So now coming to the requirement part, we have two types of requirements, that are hardware requirements and software requirements. In hardware requirement, first operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDEL, that is 3.7 version is required. Now coming to the methodology part, first upload Corel image dataset. The first step in this process involves uploading the Corel image dataset into the system. The Corel image dataset is a well-known benchmark dataset that contains a diverse collection of images representing various objects, scenes and patterns. It serves as a foundation for testing and evaluating the performance of different image classification algorithms. Second, pre-process images. After uploading the dataset, the image undergo pre-processing to ensure that they are in a suitable format for further analysis. Pre-processing involves tasks such as resizing images to a standardized size, converting them to grayscale or RGB channels, and removing any noise or artifacts. Third, run neural networks algorithm. Once the images are pre-processed, a neural network algorithm is employed for image classification. Neural networks, especially deep learning models, have demonstrated remarkable success in image classification tasks. The neural network is trained using the pre-processed images and their corresponding labels from the Corel image dataset. Fourth, run decision tree algorithm. In this step, a decision tree algorithm is utilized for image classification. Decision trees are supervised learning algorithms that partition the data based on feature values to create a tree-like structure for decision making. The decision tree is trained using the pre-processed images and their corresponding labels. Fifth, run Bayesian networks algorithm. The Bayesian networks algorithm is employed to further explore image classification. Bayesian networks are probabilistic graphical models that represent the relationships between variables and their conditional dependencies. In this context, the algorithm uses Bayesian inference to calculate the probability of an image belonging to a specific category given its observed features. Sixth, run KNN algorithm. Here KNN stands for K-nearest neighbors algorithm, is utilized as another approach for image classification. It is a non-parametric algorithm that assigns labels to new images based on the majority class of their K-nearest neighbors in the feature space. Sixth, comparison graph. To evaluate and compare the performance of the various algorithms, a comparison graph is generated. The graph typically represents the accuracy or other relevant evaluation metrics of each algorithm on the Corel image dataset. This visual representation aids in identifying which algorithm performs best in classifying the images and allows for a comprehensive comparison of their strengths and weaknesses. 8. Classify test image with visual words. Finally, after training and evaluating the different algorithms on the Corel image dataset, the system can be used to classify new or unseen images. The test image is pre-processed to ensure it is the correct format, and then it is presented to each of the trained algorithms. Each algorithm predicts the category or label for the test image based on its learned model, and the final classification results are obtained. So now coming to the execution part. To execute the project, first we need to open the code folder. So here we have a folder named as dataset. In this we have some of the folders. And in all these folders we are containing images over here. Next we have a folder named as model. In this we are containing .npy files. And another folder named as test images. In this we are containing images for testing it. Another two files that are classify images and image processing. These two are the Python files which are containing the Python script in it. And here this is the main Python file. And here this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. So here this is the graphical user interface. With this we are interacting with the program. Now click on upload Corel image dataset button to upload dataset. So here we have a folder named as dataset, and now click on select folder button to load the dataset. So here on this screen dataset loaded, and now click on pre-process images button to read color and gray features from images and build train data. So here on this screen you can see that application found total images in dataset is 888 and using 700 images for training and 178 for testing. Dataset contains total 10 different types of images, and now dataset is ready. So now click on run neural networks algorithm button to train ANN with the given images and to get its accuracy. So now here on this screen we can see ANN accuracy, sensitivity, specificity, and similarly run all algorithms for this. So now here we can see for all algorithms we got accuracy, sensitivity, and specificity, and from all decision tree is giving high performance. So now click on run decision tree algorithm over here. So now you can see over here that decision tree is giving high performance. And now also click on run Bayesian networks algorithm. So among all these we can see that decision tree algorithm is giving high performance over here. And now click on run KNN algorithm. Among all these also we can see that decision tree is giving now also the high accuracy. So now click on comparison graph button for getting the graph. So here in this graph you can see that x-axis represents algorithm names and y-axis represents accuracy, sensitivity, and specificity. And now so closing this graph, click on classify test image with visual words button to upload test image and for getting the result. So suppose here I am selecting this image, and now click on open button to get the output. So here on this screen we can see image classified as beaches over here, and this result you can see in image title bar also, and in green color text also. Similarly you can upload other image and test. So now close this image. So now coming back to the conclusion part. In conclusion, implementing data mining approaches to classify images with visual words marks a significant milestone in advancing image classification capabilities. By combining the strengths of data mining techniques and visual feature extraction, this approach addresses the challenges of complex image data, leading to improved accuracy and efficiency in image analysis. With the ability to recognize intricate patterns and relationships within images, the system has demonstrated higher precision and reliability in classifying images across diverse domains.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.